So hopefully 7-6 went well with the worksheet. I split this into 2 days just because modeling is usually pretty tough. Problems are pretty tough for people. So the second day we're going to talk about compound interest and continuous compound interest formula. So the compound interest formula is A equals P times 1 plus R divided by N to the NT. The A is going to be your final amount, usually your answer that you're solving for. Your B is going to be your initial amount. Your B. Should be P there, sorry. Your R is your rate still. Remember, we want it to be a decimal. So usually it's a percentage. We got to convert it to a decimal. Your N is the number of times it's compounded. And then your T is your time. So if we don't do compound interest, we do continuously compound interest, which looks a little bit different. It has a lot of similar features. So it says a total of $10,000 is invested at an annual interest rate of 5.75%. Find the balance of the investment after 5 years. So annually, the big thing here is in that formula, we're going to use the compound interest formula, but it means N is 1. That's what annually means. So I'm going to take $10,000, 1 plus my rate as a decimal is 0.0575 divided by 1, and then 1 times 5 to give me my time. So again, I would simplify this and make it 5. I would simplify this. So when you type this into your calculator, I would do the parentheses first. So I would do 1 plus 0.0575 divided by 1. Press enter. I would raise it to the exponent, and I'd multiply it by 10,000. And you should get 13,225. And again, I would practice this on my calculator to make sure I got the right answer. All right. One that I kind of skipped, semi-annually, if you see that word. So annually means 1, semi-annually is 2. I just did put it on here. Quarterly, that means 4 as your N. So we're going to use the same numbers, but let's look at how it affects it if I compound it quarterly instead of annually. So again, I would type in the 1 plus 0.0575 divided by 4, press enter. This time I'm going to raise it to the 20th power because it's 4 times 5. And you should get $13,303.65. And again, I would practice this just to make sure I got it correctly. Monthly, your N is 12. We're using the same numbers, but now we're going to change it to our N is a 12 instead of a 4. And it's 12 times 5. Again, practice type this into your calculator. You should get $13,321.76. Lastly, you have daily. Daily, there's 365 days in a year. So I would take 10,000 times 1 plus 0.0575 divided by your 365 raised to the 365 times 5. So this one, you should get 13,330.60. And then lastly, they throw in a continuously problem. That's a completely different equation. That's the one that we wrote down right here. So my initial amount is 10,000, but now I'm going to use the base E. My rate is 0.0575 still, times my time, which is 5. So I would type that into my calculator. I would figure this out first, and then say E to that power, but you should get 13,330.91. If you did not get any of those numbers, we'll type it into your calculator. You need to reach out and let me know so we can set up a Google Meet so you understand how to operate your calculator, because that's what the Hawks is going to be. Alright, so now it says you decide to invest $10,000 for 6 years and you must choose between 2 accounts. Option A pays $7,000 or $7,000, 7% per year, compounded monthly. So let's set this up. We still have $10,000 as our initial amount. 1 plus our rate is 0.07 as a decimal. Monthly is a 12, and then it's 12 times 6 is the exponent. So you should get $15,201.06 for option A. Option B says it's compounded continuously, so we're going to use the continuous compound interest formula. So that's 10,000 times 1, not 1, sorry, e raised to the 0.0685 times my 6. So this one you should get 15,083 cents, or $83.25. Now this one's a little bit different because it had a different interest rate. Which option is better for you to invest your $10,000? Well, it's clearly option A because you make more money. All right. Next one, it says Fred Flintstone has won the Bedrock Lottery. Since it is in the Stone Age, he has only won $500. He places it in an account that pays 6.75% interest compounded continuously. All right, so if I write a function, the function's going to look like this. I don't know the time. That's 0.0675 times t. So then it says how long will it take Fred's money to double? Well, if I double 500, that's $1,000 bucks. So I'm going to divide by 500. I get 2 equals e 0.0675t. Now how do we get rid of the common base e? We take the natural log of both sides. So again, natural log and e are going to cancel. So I get 0.0675t. You get 10.27 as your t, which is about 10 years for his money to double. All right, modeling with logs. I threw in some specific examples from the Hawks just to kind of help you out. So it says the revenue function is given by R of x, which is your revenue, is equal to x times P of x dollars, where x is the number of units sold and P of x is the unit price. So it says if P of x equals 49 times 2 to the negative x over 7, find the revenue if 14 units are sold. So again, the revenue is x times P of x. Well, we know x is 14, but we don't know the unit price. So we've got to find the unit price. So let's plug in 14 and solve it. So I'm going to get 49 times 2 to the negative second, which is 49 times 1/4, which is 12.25. So our unit price is 12.25. So now I'm going to take that 12.25 and I'm going to multiply it by 14 to get my revenue of $171.50. So the issue with this one is it's pretty easy because you're just plugging in the 14. Then people want to stop here. But remember, that's just for one unit. I bought 14 units, or sold 14 units, so I need to multiply by 14 to figure out how much money I actually made. Okay, another example of a Hawks question you're going to see, it says a certain species of a deer is to be introduced into a forest, and wildlife experts estimate the population will grow to P of t equals 299 times 3 raised to the t over 2, where t represents the number of years from the time of introduction. So step 1, it says, what is the tripling time? Well, if you notice this, I'm already multiplying by 3. So I just need the exponent to be 1. So you got to ask yourself, what do I need to plug in for t to make the exponent 1? Well, hopefully you know it's got to be 2 because 2 divided by 2 gives you 1. So after 2 years, that's when the population will triple. And that's kind of like a trick question almost. Now the harder one, it says, how long will it take for the population to reach 8,073 deer? So I'm going to say 8,073 equals 299 times 3 to the t to the negative second. So again, kind of solving these, we divide by 299. I get 27 equals 3 to the t divided by 2. Now here's where it comes into handy, knowing how to solve an exponential equation. Look at 27. Can I rewrite it as a base 3? Well, the answer is yes. I can rewrite this as 3 to the third. So now that you have the same base, I can get rid of it. I'd multiply both sides by 2. I would get 6. So it's going to take 6 years for it to reach 8,073 deer. Again, that's a specific problems from the Hawks. So your homework is going to be Hawks assignment 5.2. If you guys have any questions, let me know. We are going to take a test, and I'll send out details for how to do the test. We'll spend 2 days reviewing and then 2 days testing, and it'll be on a Google Meet. So if you have any questions, please let me know.